Welcome to the third module of this introductory course to cybersecurity. I'm sure you enjoyed the first and the second section. And in this third module, we'll be looking at navigating the pillars of cybersecurity. So this is a really important module, and I want you to pay utmost concentration to this module, okay? So let's get started without wasting much time. So the fundamental of security, let's look at the fundamental of this entire cybersecurity that we're talking about. So remember I mentioned CIA, or some people call it AIC, so that you will not think it's the CIA in American intelligence. No, not that CIA. This one is for cybersecurity. So the C represents confidentiality, the I represents integrity, and A represents availability. So these are like the main stuff in security. So if you know how all this works, if you know the reason for this, then you've understood the idea of cybersecurity. You've understood the need for cybersecurity. So let's look at the first one, confidentiality. So this confidentiality, just like the word entails, prevents disclosure of data or information to unauthorized users or systems. So in your organization, you should implement things that would help to improve confidentiality. So any data or information that is not supposed to be out there shouldn't be out there. Okay. The next one is integrity. So messages, data, or software or any entity cannot be modified without notice, which means nobody should be able to modify maybe a Word document and then you wouldn't notice. Nobody should be able to modify a software, maybe a game software. Nobody should modify it without you knowing. So that's integrity. The moment it's modified, integrity is breached, and then it's a security problem. The moment a data that is supposed to be only for the management leaks to the public, then it has breached confidentiality. Then there's a problem with the security. Availability, which is the last one, systems and network must be up and running. So the moment something is taken down, the moment something goes down, it can affect your security. So these are like the three pillars of cybersecurity. So once you hear about the three pillars of cybersecurity, your mind should go to confidentiality, integrity, and availability. So these are really important. So let's just take each of them, let's break down each of them so that you will see what they all entail. So confidentiality means certain information should be shared to only specific people. Your password should be confidential. Your account, whatever is in your account balance, should be confidential. There's some data that you know in your organization should be confidential. The moment they're out there, then there will be a problem. So what are the ways to ensure confidentiality? Since we've agreed that confidentiality is really important in security or in cybersecurity. So what are the ways to ensure confidentiality? The first thing is encryption. So we should encrypt or encode messages so that only certain people can decipher and read the message. For example, you want to write a letter to me, and instead of just writing the letter directly, you write it and then you put it in a box, you lock it with a key, and then you send it to me. So if you send it via DHL or via Jumia ride or whatever rider, if the person does not have the key to unlock it, so you put the information inside a box, you give the rider to bring it to me. The rider cannot access that information because it's encrypted, it's locked. No matter what the rider does, it cannot access that information. It's only when the box gets to me, I will now pick a key because I have a spare key to that box. I and the person that have been communicating, we have the keys to it. Let's say a padlock has like 4 keys, and now let's assume this key or this information we are talking about, this letter, is your WhatsApp chat. That person that you're chatting with at the other end in WhatsApp has a key to that padlock. Me too, I have a key. So this person is sending the delivery driver. I hope I don't want to confuse you. The delivery driver is supposed to send information. The information will not just be, oh, take this letter, without locking it, without doing anything. The rider can read it and you wouldn't know. It could be a sensitive information that if the rider reads it, it could say, so this thing happened, and it will start broadcasting it everywhere. But by the time you put it in a box, lock it, he sends it to, he wouldn't be able to read it, but he sends it to me. I just go to where I have the key and unlock it and then read it. And if I want to respond again, I'll have to respond. I can write back in the paper, in the message, put it in the box, and send it back through another delivery driver. So that's how encryption happens. That's how communication happens basically on the internet. The WhatsApp communication you have with someone else, that is why nobody else can see it, because it's been encrypted, it's been locked. Only the people with the key can see it. So that's the idea behind that. So encryption is really important. Then the second thing is access control. So this is to restrict the type of access provided to a resource. Okay, so access control is only certain people should have access to this. I'm not going to give you the password to this because it's confidential. You don't have any business knowing this information. You don't have any business knowing this, so I'm not giving you access to it. You don't have any business entering that place, so I'm not giving you access to it. So that is what access control is. There are lots of technologies, lots of tools that help with access control. Either access control preventing you from entering a building, or access control preventing you from logging into a computer, or access control preventing you from seeing a particular information. So that is what access control is. It's helping to ensure confidentiality, that it's confidential. Only the person that is supposed to see it would see it. Then there's steganography. Okay, so this is not commonly used, but it's still used somehow. Okay, this is to conceal information within another piece of information. For example, I'm sure most people don't know that if I send an image to you, perhaps we are two cybersecurity people communicating. There's me, there's my friend. I could send an image to him. There could be an information that is hidden in that image that we are sending. It could just be a random image, but I could have written something and fused it with that image. So what every other person is seeing is just an image. But the person I'm sending it to already knows that there is an information that is supposed to see in that image. So he uses special tools to be able to crack it and see the information that I'm trying to pass across. Okay, so they use this in the past to communicate. Some even still use it now. All those top hackers or malicious hackers and normal hackers still use steganography to conceal information. Okay, then there's cryptography, which is concealing message with secret code used, and this is mostly used in military communication. There's policy implementation. So in most organizations, they implement cybersecurity and information policies, and some sign NDA agreements on who should have access to the data. For example, if I'm not supposed to know something, and maybe I'm in an organization, I've automatically signed an NDA. Any organization you join, as you're entering, you're signing what they call an NDA, non-disclosure agreement. So this is telling you that any information in this bank is confidential. Okay, if you hear that the organization is about launching a new app, it's confidential. You shouldn't be saying, "Oh, we are about launching a new app that can detect sound waves," or you're not supposed to do that, because the moment you do that, you are giving competitors idea on how to use your same idea. So that is what an NDA does. It's restricting you. It's a signed document. It's a policy implementation that is preventing you from doing that, because you will see on the document that you signed that if you end up telling people about it, you could face jail time, you could be locked up, you could pay a fine, depending on the information and how sensitive it is. Let's look at integrity. So this is another important part. Data is stored, shared, and modified as intended. That is what integrity is supposed to ensure, that data is stored, not just stored, it's shared and modified as intended. Okay, so the goals of integrity is that any unauthorized modification would be noticed. So if I send a Word document to somebody and then the person modifies it and sends it back to me, I should know that this document has been modified. Another goal of integrity is to ensure non-repudiation. That is non-denial. You cannot deny that you did something or you sent something. For example, if you sign a particular document and then maybe you sign off a document of transferring $1 million to somebody, ₦1 million to somebody, you cannot later say, "Oh, I didn't sign this document," because there are security solutions that ensures non-repudiation, like digital certificates or digital signatures, that ensure that once you sign something, you cannot deny that you did not sign it, because nobody can manipulate it. And if they manipulate it, it will show that someone has manipulated this thing and you'll be exonerated. So that is what integrity does. So we have three we have three major things we need to look at when it comes to integrity. Please pardon these figures here. I was trying to do something. We have hashing, and the use of hashing. For hashing, we use hashing algorithms. I don't expect you to know in depth what all these things mean, but I will try to explain them. But I'm sure with time, as you go through, as you progress in your cybersecurity journey, you would understand and even get to practicalize and see how all these things work. So there's what we call hashing. So they are hashing algorithms, and they are used to like, it's just like putting a tag on a particular stuff. Okay, so for example, if I purchase my phone, it could have a tag that says the tag of this phone is 123456. Okay, but the moment the tag has been recorded, the moment the phone leaves my hand to somebody else and is now showing 248610, then you know that something has happened. That is not the phone I bought. The phone I bought was 123456. That is the hash of that phone. But now I'm seeing the phone that you sent to me or that you gave me that is 2468, and you're telling me it's my phone. This is not my phone. So there's no integrity there. So what hashing does is that it ensures integrity. So once that hash changes, once the number changes, then there's something wrong with it. Hashing is used in most softwares that we download, or most applications that we download. For example, if you are downloading Photoshop software or Google Chrome software, that Google Chrome software has its hash. The Photoshop software has its hash. You can search it. You can just search for the hash of this software. So most even on their websites, they will make sure they write the hash, and there's a way you can check it. There are hashing softwares you can use to check it. So if, for example, someone now sends you a Photoshop, someone says, "Oh, I have Photoshop, let me send it to you," and the person sends it to you, and then you compare the hash or you check the hash and it's different from what it's supposed to be, you will know that it has been modified, that something is wrong with that application. Either it's a malware that a hacker has crafted to look, or a Trojan that is crafted to look like your Photoshop software. It is not the same. Something has changed. There's something wrong with this particular application. Either it has been modified or it has been corrupted. So that is what hashing is. Then we have digital signatures, which uses mathematical schemes to work, or that's how it works. It works with mathematical computations. So we see digital signatures for signing. I know there are some people that sign documents with hand, but you could use digital signatures like Simply Sign and the other ones that we have out there to help you sign your document. So when it signs the document, it automatically puts the name, your name, your signature, the date it was signed, the time it was signed, all those things are there. So if anything happens, if someone modifies anything on that document, if someone adds a word or a letter, as small as a letter, if someone adds a letter to that document, to that Word document or to that PDF document, then if you check if you check again, if you use your software to check that digital signature, you see that something has changed. It will notify you that something has changed, something, either a figure or something has changed. So this will help you to make sure that the integrity is restored. Then we have certificates. Okay, this is usually used hand in hand with digital signature. So certificates are digital certificates that make sure that there is sort of integrity, and it's used to verify different individuals. Okay, either a bank could be using a certificate on their website, and you would understand much of this when you move further in this course or in your career path in cybersecurity. Then the third one is availability. So for availability, information or data is always available and accessible to authorized users. The key word there is authorized users. If you are not authorized, you shouldn't have access to the data shouldn't be available to you. So I think there are two keywords here: available and always available, and authorized. So the data must always be available and is for only authorized users. So let's look at the three important things when it comes to availability. So we have fault tolerance. So this means that your system runs even when there's a failure. Okay, it might not be as effective as the main one. For example, if there is a server. Remember I told you a server is like a computer that is supposed to send out information to other small computers, or is used to store information for others to access. So for example, now a server goes down, or maybe it crashes or something, that shouldn't just be the end of the data. For example, now I'm trying to look for a suitable example. YouTube, for example, okay, YouTube has a particular or different servers where they have their all the videos you upload on your YouTube channel, on your Facebook Reels, your TikTok, all those things are entering a particular computer called a server. So all those videos that are entering there, what happens when that particular server crashes? Does it mean your account will just shut down, all the videos will stop showing? No, the reason it does not happen that way is because there's what they call a backup. It's more like a backup. So as they are putting all those videos they're uploading on that server, they are duplicating it to another server. So you have like there's a replica of that video you uploaded on YouTube. It's also on a different server. It's in a different computer. So if this computer crashes, it automatically switches to this other one, and you still have access to your videos. People will still be able to view your videos. So that's what fault tolerance is. So redundancy also is having a duplicate running somewhere else different from the location. For example, multiple routers, multiple switches, multiple servers. Okay, it should be in different locations other than the main location. This is almost similar to fault tolerance, but redundancy is just making sure that there's a duplicate running somewhere else different from the building. For example, this is a building, a server room that has lots of computers that send the information to other computers. What happens when fire burns the place? Does it mean, and imagine putting all the backup and everything in one place. What now happens to the backup and everything when fire burns everything? It means everything will go. So the smart thing to do is, as you have your normal server, your normal computer server that serves information, that let's say it's in Lagos here, you should also have another server in maybe Kaduna or maybe in the US or somewhere that has the same information. So if maybe fire or something, maybe it gets stolen or something happens to this one, you could have it in another location. The fire that burns this entire location down would not affect this other one because it's not in the same place. So that's the idea of redundancy. And the last one for availability is patching. So patching is really important for closing security holes. So patching is just like your clothes store, and from there, if your clothes should tear, if you don't patch it or if you don't sew it, it expands from that place. Okay, so that's what patching is. Patching is just you're patching, or you are trying to fix errors or solve errors in maybe a software or in your OS on your computer, and if you don't quickly update that software, if you don't quickly resolve that problem, then you are leaving it open for more problems, and it could be hackers hacking you or your computer crashing. So this is all we need to know relating to the CIA of security. I hope you found this very useful, and I hope I was able to explain everything. Don't worry, with time, like I said, this is just an introductory course. With time, when you take other courses and you get more exposure, you would understand these things. When you see things happen, when you also remember some of the things I said, then you will say, oh, so this is what this is. So I'm sure with time you'll be able to further understand this thing. So don't forget to answer the quiz for this particular module, and then in the next module we'll be looking at detecting, defending, and mitigating cyber threats, which is basically the role of any cybersecurity professional or someone who wants to go into cybersecurity. This is what you will be doing: detecting, defending, and mitigating cyber threats. So I'll be talking about how you can deal with cyber threats and attacks. What are the control measures to put in place to detect, to defend, and to mitigate these cyber threats? So till that time, I'll see you in my next video. Stay safe. Bye, guys.